Hello guys, welcome back to this YouTube channel. Today we want to analyze truss. The question was sent to me by one of my subscribers requesting that I help him solve the problem. And the question reads, for the truss shown in figure Q2, obtain question number I, reaction at the support. Then question number II, the magnitude and nature of the forces in the members. We have represented it in the free body diagram, where here we have our vertical reaction at A and our vertical reaction at E. Like the question said, the reactions are the support. So we're going to get our VA and our VE all at the same time. Though you can call this RA and RE. So to do that, let's take moment at point A. So we can say moment at point A is equal to 0, whereby clockwise moment should be equal to anti-clockwise moment. Taking moment here, it means that this VE will cover a distance of what? 6 meters to this particular point. So we have 6 VE is equal to, all these forces will move in a clockwise direction. Then to start with, this 60 kilonewton will cover a distance of what? 6 meters. That is 60 multiplied by 6. Then plus 100 cover a distance of what? From here to here, which is what? 3. Then plus this 60 is covering no distance, so it's 0. Therefore, we have 6 VE is equal to, I will have 360 plus 300 plus 0. Therefore, our VE is equal to 660 all over 6. Therefore, our VE is equal to 110 kilonewton. Now, this particular truss is symmetrically loaded. Therefore, VE should be equal to VA, which is equal to 110 kilonewton. If you doubt this solution, you can decide to take moment at point E and do what we did, and you see that you have the same answer. Or rather, you can say let upward force be equal to downward force. In that, you are saying VA plus VE is equal to 60 plus 100 plus 60, where the value of VE is already known. So you can try that out and know what you get. So having gotten this, we're going to redraw this particular truss, whereby we're going to assign either tension or compression as the question demands, that we should get the magnitude and nature of the forces in the members. So let's quickly redraw it. In assigning the direction, we're going to apply the method we use when solving the previous problem we posted in this particular channel. So if you have not watched the problem, kindly check the description section of this video, and I believe you will see the link. So we're going to assign tension to all the members. So assigning the tension means that the force is going to be in this form. Yes, it could go like this. Go like this. And don't forget, we are using method of joints. So we're going to go from one joint to another. And to start with, we're going to start with this joint A. And this joint A, we're going to draw everything that is represented in this joint A. And also don't forget, we have 3 meters here, 3 meters here, making this particular triangle isosceles. Therefore, if it's isosceles and here is 90, this particular place is 45 and here is 45. The same thing happens here. So let's quickly redraw this particular joint. At joint A, this is what we have. So we're going to do the vertical resolution. And in vertical resolution, this is a vertical force and this is a vertical force. So we have only these two vertical forces which are moving in the same direction. So we have FAB plus 110, because so them are moving in the same direction, is equal to 0. So FAB is equal to minus 110 kilonewton. Then we resolve horizontally. We have only one horizontal force, which is FAF, and is equal to 0. Then at joint, the next joint is going to be joint B. We have joint B. So we're going to sketch whatever we see on this particular joint B. So let's go ahead and do that. So this is what we have at joint B. All these forces, they are all represented here. We have this BA, we have this BC, so on and so forth. So let's start with vertical resolution. Vertical resolution. So what are the vertical forces here? These two are vertical and they're moving in the same direction, which is downwards. And we have a 60 plus FBA. If we resolve this particular one, it will also move in the same direction, which is downward. Therefore, we have plus FBF sine 45. I hope you know how we got 45 degrees from what I explained here. If this is isosceles, this is 90. Therefore, this place is 45 and here is 45. And if here is 45, here is 45 as well. So we have 45 degrees equal to 0. Now, we already know our FAB, which is something as FBA. So we have a 60 minus 110, then plus sine 45 degrees is 0.7071, and so on and so forth. So we have 0.707 FBF is equal to 0. So our FBF is equal to 50 all over 0.707, which is equal to 70.71 kilonewton. Since our answer is positive here, it means this is tension because we assign tension throughout. And this one that is negative, it means it is compression. Then for the, let's say horizontal resolution, we have this horizontal force, which is FBC. And if we resolve this one to appear horizontally, two of them will be moving in the same direction. So we'll add it up. We have FBF cos 45 degrees is equal to 0. So our FBC is equal to minus 70.71 cos 45 degrees, which is equal to what? Minus 50 kilonewton. Since it is minus, it means it is compression. Now, let's go to the next joint, and that is joint C. So we're going to sketch everything within this joint C. Let's do that. This is what we have at joint C. This is joint C. So at this joint C, we'll say vertical resolution. What are the vertical forces here? These two are vertical forces. So you can see that two of them are moving in the same direction. So that is FCF plus 100 is equal to 0. Therefore, FCF is equal to minus 100 kilonewton. So it's going to be, the force is compression. Then for horizontal resolution, we have horizontal forces here, and we have FBC and FCD. The two of them are moving in opposite directions, so FBC should be equal to FCD. And we've already gotten our FBC to be minus 50 before. Therefore, our FCD is equal to the same minus 50 kilonewton. So this is also compression. The last joint that we're going to talk about now is joint D. So at joint D, let's represent what we have. At this particular joint, we are going to start with the horizontal resolution because this horizontal force is already known, but all this particular vertical force is not known, and this one is not known if it resolved vertically. So since we have already known this FDC, so let's start with the horizontal resolution. So we have FDC. Another horizontal here is this FDF. So we have plus, since this one will also move in the same direction, that is why we have FDF. Since it's horizontal, we have a cos 45 degrees is equal to 0. So we have minus 50, that is the value of our FDC, plus 0.707 FDF is equal to 0. So our FDF is equals to 50 all over 0.707, and that will give us 70.71 kilonewton. This is also what? This one is tension. Then for the vertical resolution, we have this vertical force moving down. This one is moving down as well. And if we resolve this one, it will also move down. So all of them are moving in the same direction. Therefore, we have 60 plus FDE, then plus FDF sine 45 degrees is equal to 0. We have 60, then plus FDE, then plus 70.71, that's the value of FDF sine 45 degrees equal to 0. So our FDE is equal to minus 110 kilonewton. So this is compression. Now, looking at this particular truss, if we should talk about this one, remember this particular truss is symmetrically loaded. So whatever we have as FAF, that is FAF, should be equal to what FEF will give us. it's symmetrical loaded. So this member and this member will be the same thing. So there's no need resolving this one again. Even if you look at this, you see that everything we have here is the same thing as what we got here from the calculation. So let's take advantage of the symmetrical arrangement and forget about talking about joint E again. But if you want to solve joint E, you can also do that on your own and know if you have exactly the same answer. At this point, we're going to summarize this answer in a table. This is how your table should be arranged. You have your joints from joint A to joint F, and then the members. The members here are already say AB, BC, so on and so forth. So to start with, at joint A, we have member AB and AF. What are the magnitude of the forces there? At AB, we got minus 110 kilonewton. You're not going to put the minus again because there's something like a negative force. It only shows that the direction you assigned is the opposite and it's compression from what we explained. Then for AF, our AF is 0. Then at joint B, we got our BA to be what? BA is same thing as AB, which is 110. Let's not put this kilonewton again since we have it here. And it's also compression. What about BC? Our BC is what? Where is it? We have our BC to be minus 50. So that is 50 and is what? Compression. What about BF? BF, do we have our BF here? BF is 70.71. 70.71. And our BF is what? Tension. Then go to joint C. At joint C, we have a CB. Our CB is something as BC. CB and BC are something that is what? 50 and is what? Compression. What about CD? Our CD, what is it? What is our CD? CD is 50. Compression is 50. Compression. What about CF? CF is 100. Compression is 100. Compression. Then go to joint D. Joint D, okay, we have DC, which is something as CD, and that is 50. Compression. We have DE. DE here is what? DE is 110 compression. 110 compression. 110 compression. Then DF is 17.71 tension. 70.71 tension. ED is something as DE, which is 110 compression. EF, our EF is what? Do we have EF here? Let's look for that. The EF, we say the same thing as AF, which is 0. Then FC, what about FC? FC is something as CF, which is 100, and that is compression. And our FB is something as BF, so our BF is 70.71 tension. What about FD is something as DF, so DF is 70.71 as well, tension. Then our FA is something as AF, which is 0. Our FE is something as EF, which is also 0. So with this, we have come to the end of this particular problem. If you find this video helpful, kindly subscribe to this YouTube channel and also share this video link to as many friends as possible.